In this video, we're going to look at determining formal charges from Lewis structures. We'll actually revisit this in Chapter 2, and I'll have a second video that goes a little bit more in depth into formal charges for that chapter. So the general rule for determining formal charges is given in this first equation, if you want to call it an equation. Right? That is, we get the formal charge by taking the valence electrons that atom has, and then subtracting from that the total of the lone pair electrons plus 1/2 of the bonding electrons. And so if I was going to look at oxygen in carbon dioxide, right, oxygen, if you look at your periodic table, has 6 valence electrons. And so I would do 6 minus, and then the number of lone pairs that oxygen has, and I don't mean just lone pairs, I mean lone pair electrons. So it has 1, 2, 3, 4. And then it gets half of the bonding electrons. And so each bond in the double bond is 2 electrons, so it has 4 bonding electrons. Right? I want to take half of those, so half of 4 is 2, and so 6 minus 4 plus 2 is equal to 0. Now, this is the formal way to say how you calculate the formal charges. This, I got the idea from Dr. Pennington, and I think this is easier to write and easier to remember. Right? You take the valence electrons, and then you subtract the number of balls plus sticks, right? Now we get the same thing, right? So I have 6 valence electrons, and then minus, right, the number of balls, 1, 2, 3, 4, the number of sticks, 1, 2. So we get the same thing. So these are both the same, but I think this one is maybe a little bit easier to remember. So the formal charge on oxygen is 0. Right, the oxygen on the right is the same, so it will also have a 0 formal charge. For the carbon, carbon has 4 valence electrons, so I'll do 4. And then it doesn't have any lone pairs, so no balls. It has 4 sticks. So 4 minus 4 is 0, so the formal charge of each atom in that molecule is 0. Okay, another example. So if we look at the hydrogens, hydrogen has 1 valence electron, minus, right, no balls, 1 stick, 1 minus 1. So the formal charge on hydrogen is 0. And in general, when you see a hydrogen with 1 bond, which is pretty much always the case, we know they're going to have formal charges of 0. For the carbon, we know carbon has 4 valence electrons, so minus, no balls, no lone sticks, or sorry, no balls, no lone pairs, and then it has 3 sticks, 3 bonds, so 4 minus 3 is 1, and so carbon has a positive 1 formal charge, or oftentimes, rather than writing positive 1, in organic chemistry, we would put a plus. Okay, another example. So in this case, the hydrogens each have 1 bond. That tells us that hydrogen is going to have a formal charge of 0. Carbon has 4 valence electrons, minus, no balls. It has 4 sticks, so the formal charge on carbon is 0. And in general, when you see carbon with 4 bonds and no lone pairs, that's going to always have a formal charge of 0. We'll see that enough that hopefully you'll come to recognize. You see a carbon with 4 bonds, no lone pairs, we know that formal charge is 0. For the oxygen, oxygen has 6 valence electrons, minus 2 balls. It has 3 bonds, 2 from the double bond, 1 from the single bond of the hydrogen, so it has 3 sticks. So 6 minus 5 is 1, so hydrogen has a positive formal charge. And then this hydrogen, like the others, has 1 bond, so it's 0. All right, one more example on the next slide. All right, so all my hydrogens have 1 bond, so they all have a formal charge of 0. Both of the carbons have 4 bonds, no lone pairs, so I know they're going to have a formal charge of 0. And when I look at the nitrogen, nitrogen has 5 valence electrons. There are 4 balls, 2 sticks, so 5 minus 6 is -1. So nitrogen has a negative formal charge.